what I will be talking about is exactly what I'm showing. I'll be talking about this multi-device speech transcription and translation service that we provide through Microsoft Translator. And I'll talk a little bit about the technology behind it, how it was developed, and the kinds of problems that you run into dealing with conversational speech, which even a lecture like this is still conversational. So how you actually deal with problems in conversational speech. So a little bit of background. I work for the Microsoft Translator team. Our focus is on machine translation. It has been since I started there a decade ago. It came out of a research project starting in 1991 that ultimately became a product in 2007. And that was focused on text translation. So being able to translate documents from one language to another and doing that automatically. And the quality has improved dramatically over the past decade. In 2014, the technologies had improved to the point where it became possible and viable to actually look at speech translation. There have been efforts over the past decades to do speech translation, but really the computational power wasn't there until fairly recently. And so we started a project. I'm going to minimize the captions now. We started a project. It was kind of a skunkworks project on the sly, if you will, kind of developing this technology starting in 2014, and then released Skype Translator in 2015. Skype Translator being a product where you can actually call via Skype someone somewhere else who speaks a language other than your own and be able to communicate with that person with the translator mediating that conversation. And then finally, we've released in-person tools like the one you're seeing right now in PowerPoint and through different clients for in-person scenarios like the one we're in currently. So this is kind of inspired by Star Trek. And you probably, if you're a Trekkie, you'll recognize this picture. So there's the lizard man here on the right, the Gorn, which I bet I don't translate correctly at all. So I'll just call him the lizard man. And he's talking to Captain Kirk via this device. So it's a handheld translator. And so they're actually talking to each other. So this is very much the scenario we've implemented. Okay, it took us 50 years to get here, but if you think about it, Star Trek set 200 years in the future from 50 years ago, so we're actually 150 years ahead of schedule. So this is the speech translation overview here, and it kind of shows the audio input coming in, and then it goes to the cloud, does the transcription of that audio input, does the translation, and then produces translated text. It can also produce audio, so that you can, if you're on a client that supports audio, you can actually listen to audio like on a headset and actually hear the audio of what I'm saying as well. It's optimized for conversations, and that's crucial. Speech recognition, for the most part, much of the technology now that exists in other platforms is focused on command and control. So you talk to a device and say, I want this, or I want that. Usually you think these things through before you say them. They're not conversational. You're not actually having a conversation with the device. This is different. What I'm doing right now is conversational. If you were talking to me in another language, we would be having a conversation now. And the kinds of problems you have with this is much more difficult than a command and control scenario. Currently we support 10 speech languages. We just released Japanese 2 weeks ago. And we support 61 text languages. What that means is that I can speak in any of those 10 and generate transcripts in any of those 61. And then I think there's a subset of those that produce audio, about 18 of those. And it runs in Azure. These are the platforms that we currently support, so various devices, handheld devices and computers. And it's also integrated into Skype Translator, as I indicated earlier. The company's in the process of integrating into the Skype for Business platform. So there's a Skypecast, which allows you to have a lecture, for instance, and then have maybe 1,000 people in the audience, and they're all getting transcripts broadcast from that lecture. So why now? Why is this technology viable? And I don't know how many of you are following the transcripts. There are errors in there, but if you look at it, it's not too bad. You can definitely follow it. Why now? And really what started happening around 2011 with what we call deep learning or deep neural networks. This technology, the introduction of this technology really was the significant shift that was required for speech recognition to get to a point where it would be viable in this kind of scenario. So we saw a 33% reduction in word error. Now that's the way we measure quality in speech recognition. Word error, lower the number, the higher the quality. And over the previous 15 years, if you got a 1% reduction, that was a cause for celebration. 33% reduction is just mind-blowing. That was something that was completely unanticipated. And we're now hovering around 42%, even some research now close to 50%. Same data, same more or less training algorithm, except you're using deep learning versus the older models, which were called Gaussian models. Also, large amounts of data, just have huge amounts of data now that we didn't have 15, 20 years ago. Robust and fast training infrastructure. Here's the computational power. To train on devices from 20 years ago, it would take a year. To train on devices now, maybe a day, especially if you distribute the process. And then finally, translation has also entered this realm of deep learning. So this technology comes from Jacob, who's the author of this paper here. He's one of the fathers of the field on neural machine translation. I work closely with him. He's probably one of the smartest people I know. Father of the field, he's not 30 yet. I think he's 29. So pretty soon we'll have 15-year-olds being fathers of the fields, I guess. But it's awe-inspiring actually working with him. He really knows this technology. So how speech translation works, again, this audio signal comes in and goes through the deep neural network, generates the transcript. And then really here's where the hard part happens. Because the transcript that's generated is conversational, there's lots of ums, uhs, and pauses, and restarts, and these kinds of things. And we have to run it through a process to clean that stuff up. Our minds filter that stuff out. It's actually really difficult to perceive it unless someone really is pausing a lot. You don't even notice it. To replicate that is the hard part. And so people don't talk the way they write, and they're amazingly disfluent. I don't know if you've ever looked at raw transcripts from any talk you've given. If you are talking to people and you look at the raw transcripts, you go, this person is completely daft. I mean, it's like, how could anyone possibly understand anything I'm saying? So that's the problem, is getting that cleaned up so that it looks like a caption. And then people don't talk with punctuation either. So you have this kind of stream of consciousness that's going on. That's actually also very difficult to read. You have to introduce punctuation and casing and this kind of stuff to make it more readable in the monolingual context, let alone the bilingual context. If I want to transmit these transcripts into another language, I have to clean it up, or it's just nonsense. And so this is the challenges are compounded in translation. So here's a good example. This is from an actual conversation. So at the bottom down there, the person said this. They thought they said this. And the people that heard them thought they said that. So you don't see all of this fluff in there. That all goes away. You hear this, more or less. And if you translate what's down here at the bottom, if you guys read German, you get something that looks very weird. If you read Chinese, you get something that also looks weird. It just is not readable. There's, like, the one thing that drives people nuts is, do you know pause in English? That's one of the pause words in English is you know. We throw that in all over the place. People look at you like, what do I know? Why do you keep saying I know something? Stop saying I know, people, or you know. It drives people nuts. So we have to deal with that. But the problem is, it is also a valid expression. So you can't just strip it out. You have to strip it out where it's important to strip it out and not in other cases. So we have to get it down to something that looks like this. And then this is actually much more readable. So it's more than just ums and uhs. And by the way, when I'm talking about these constructs, the transcripts go wild because it starts stripping things out because I'm actually talking about them. It doesn't know what to do with them. So this is not a good example of a talk where it actually behaves well. And so here are some examples of the kinds of disfluencies that you see in language. I won't go through all the details here, but these are the kinds of things we have to we've actually developed models that are able to remove these. So I'll give you some examples here that are kind of amusing, and we struggle with some of these. So here's Spanish on your left and English on the right, and there's very, very minute differences between the two of these. One is a question and one is a command, and it's only a tonal difference that tells you that there's a difference. And frankly, we don't get this right all the time. So you're in a conversation and someone says, "Go now," and it's like, no, he's asking me a question.